Lesson 23, Operations with Radicals. In this video, we'll talk about mainly adding and subtracting radicals. The first step is trying to, in example 1, break down the 18 18 has a perfect square root factor of 9. So we can break down 18 as 9 times 2. Because we know the square root of 9 is 3, and 2 stays inside the radical. Multiply the 5 and 3 together, gives us 15 on the square root of 2. Now, if you have the same radical, you can combine these together like terms, like combining x's. So 15 minus 2 is 13 on the square root of 2. It's like saying if you have 15 root 2's and I take away 2 of them, then you'll have 13 square root of 2's left. The next example, you have cube roots. Six times the cube root of 250 plus the cube root of 54. This time around, you want to find the highest possible factor that's a perfect cube root. So for 250, we can break that number down as 125 times 2. And for 54, we can break that down as 27 times 2. Now we know the cube root of 125, that's equal to 5. And cube root of 2 stays inside. And we also know the cube root of 27, or in other words, what number can you multiply 3 times to give you 27? And that number is 3. So we have 3 cube root of 2. This is 30, by the way. And because we have the same cube root of 2, these are like terms, and you can add them together. So 30 plus 3 gives us 33 times the cube root of 2. Very important. If you're given a root other than 2 and you got stuff left over inside the radical, bring down the given root. The next example involves subtraction and addition. We have 8 times the square root of 300 minus 4 times the square root of 243 plus 7 times the square root of 147. With large numbers, it's trial and error trying to figure out the highest possible perfect root. For 300, let's try 100 times 3. For 243, let's try 81 times 3. And for 147, let's try 49 times 3. The square root of 100, we know that is 10. So 8 times 10 is 80. Square root of 3. Square root of 81 is 9. Times negative 4 is negative 6, square root of 3. And square root of 49 is 7. Times 7 is 49 on the square root of 3. And the last step is to combine all of your square root of 3's together. So 80 minus 36 is 44. Plus 49 gives you 93 on the square root of 3. Our next example involves both numbers and variables. We have the sixth root of x to the fifth times y minus the sixth root of 64 x to the fifth times y. We can't break down the letters because if the inside exponent is less than the root, then your letter is already in simplest form. So we can bring down the first part. The sixth root of 64, if you put that in your calculator or figure it out by hand, that gives you 2. And the x and y remain inside the radical. Again, we have like terms, so we can combine them together. 1 minus 2 gives us a negative 1. 6th root of x to the fifth power times y. And that's our final answer. Next up, let's look at a word problem involving addition or subtraction of radicals. Sorry, this is hard to read. We're given a triangle, and these are the sides in inches. And we must find the perimeter. Perimeter means add the sides. So we have 5 square root of 27 plus 4 square root of 48 plus square root of 125. And break down each radical if possible. 27 we can break down as 9 times 3. 48 we can break down as 16 times 3. And 125 can be broken down as 25 times 5. Go to each radical and take the square root. The square root of 9 is 3. Times 5 is 15 square root of 3. The square root of 16 is 4. Times 4 is 16 root 3. And the square root of 25 is 5, leaving 5 inside the radical. The only radicals we can combine, since they're like terms, are the square root of 3's. So this would be 31 square root of 3 plus 5 square root of 5 inches. And that's as far as we can go. In the next video for lesson 23, I'll discuss how to multiply and divide with radicals.